Okay, so bile salts. So bile salts are a chief component or major component of bile, naturally. Pretty self-explanatory. And so bile aids in the digestion of lipids and it works primarily by emulsifying the lipids that are obtained in diet. Okay. So the idea is through emulsifying these lipids that are in the diet, so increases the surface area exposed. Okay, so it's emulsifying them, increasing their exposed surface area, leading to hydrolysis. So things like the triglycerides, hydrolysis of the triglycerides, or any other components of the lipids that are hydrolyzable. And of course, making sure that action of lipases is improved as well. So it makes this hydrolysis or action of lipases more efficient. Okay. So just by emulsifying them, increasing the surface area that's exposed, it improves the efficiency of hydrolysis and the action of lipases. So it gives lipases a little bit more access to these lipids since they're not kind of clustered up together and excluding other things. And also the same thing, it increases the availability of these lipids to solvent, allowing them to be hydrolyzed more readily. Okay. So they also serve to emulsify excess cholesterol. And this allows it to pass into the small intestines. And of course, eventually, excretion. So one of the principal bile salts is something called sodium glycocholate. So we'll draw the structure of that for you to have an idea of what this is. And again, you notice that the basic underlying structure is that 4 fused rings, the 3 6-membered rings and the 1 5-membered ring. So the basic structure is the same, underlying structure is the same. It's just modifications of that ring skeleton, that fused ring skeleton. sodium, glycocholate, and as mentioned, it's one of the principal bile salts, so it's present in probably one of the most abundant bile salts that you have. Okay. So now I want to talk a little bit about the steroid hormones. So there's things like the adrenocorticoid hormones, things like cortisol and cortisone, aldosterone, and then of course the sex hormones. So let's talk a little bit about those. I'm still in the category of steroids. So steroid hormones. So there's two major classes of steroid hormones. And these are your sex hormones. Things like estrogen, progesterone, testosterone, and then of course your adrenocorticoid hormones. I'm going to talk about the adrenocorticoid hormones first, and then we'll talk about the sex hormones after that. So, as the name might suggest, the adrenocorticoid hormones are produced by the adrenal glands. The adrenal glands are those glands that are sitting on top of your kidneys. So you've got two subtypes of adrenocorticoid hormones. So two subtypes, or what I'm calling subtypes. And those are your mineral corticoids. And so these regulate concentrations of ions within your body fluids. So things like potassium and sodium. So it's helping to regulate those. So the other type are the glucocorticoids, which are things that are involved in carbohydrate metabolism, typically enhancing carbohydrate metabolism. So their name, as it suggests, glucocorticoids, glucose. So basically metabolism of carbohydrates. So in terms of your glucocorticoids, so you've got cortisol. This is a glucocorticoid. That basically serves to increase glucose and glycogen within the body. Oftentimes you'll hear that cortisol is your stress hormone. So basically in response to stress, it's increasing blood glucose. However, long term, this can lead to deposition of fat in tissue. So it increases storage of fat. So long term. Okay, so and we can recall from the chapter that we did on carbohydrates, glycogen is basically the major storage in the liver and muscle for glucose. So cortisol and cortisone which is sort of a ketone derivative of cortisol. And I'll show the structures of those in a moment. Are anti-inflammatory. So oftentimes these are used for treatment of inflammatory conditions. So oftentimes people with arthritis or other kinds of inflammatory diseases might end up with cortisone shots to help treat the inflammation and reduce the swelling and the pain. Of course, synthetic derivatives of these to help make them a little bit longer lasting are often used in those kinds of treatments. So. And of course, cortisone and cortisol derivatives are often used in treatment of asthma as well, because that's usually considered an inflammatory disease or an inflammatory illness. Okay, let me sort of show you a little bit more about cortisol, cortisone, and a synthetic derivative of that. One thing that I sort of want to step back and talk about a little bit is in liver, I talked about cortisol being involved in increasing glucose and glycogen in the body. Talk a little bit about how that does that. So let's and then I'll show you the structures. So as I mentioned, cortisol increases glucose and glycogen in the body. So this usually, in this particular process, is taking place in the liver. So we've got lactate plus your amino acids. So this is usually from protein. So when you're breaking down protein to form the amino acids, combination with lactate, and then through a series of metabolic steps initiated by cortisol, causes glucose release or production. So production of glucose, and then storage of that glucose in the form of glycogen. So this takes place. So imagine being under stress, your body needs extra energy, so it produces, glucose from things like lactic acid and the breakdown of protein, or just protein in general, to form or to increase levels of glucose in the blood. And then, of course, that glucose is used for energy. So when you're under stress, you're using more energy. But of course, the excess glucose is then converted into glycogen and stored in the liver. Okay. Let's show a couple of structures for cortisol, cortisone, and a synthetic derivative called prednisolone. Oftentimes, if you have bronchitis or something like that, cough that's not going away, or one of those barking coughs, typically they'll give you something like prednisolone or methylprednisolone to help reduce the inflammation so that your body can help deal with the cough and what's causing the cough. Okay, so helps you breathe a little bit better so that you're not struggling for breath. Okay, so cortisol looks like this. So this is cortisol. This is cortisone. So this is cortisone. And you'll notice that the difference between these two, so this is an alcohol versus a ketone. Okay, so that's the difference between those two structures. As I mentioned, cortisone is just a ketone derivative of cortisol. And then, of course, we've got prednisolone, which looks like this. And so So this is a synthetic derivative, and of course it's very closely related to cortisol. The only difference, of course, being the presence of this double bond here. Okay. Okay. So now let's talk a little bit about aldosterone. So this is a mineralocorticoid. So it's, as I mentioned before, mineralocorticoids are important in regulation of absorption of ions. So regulating the presence of ions in the body or the body fluids. Aldosterone is probably one of the most important mineralosteroids or mineralosteroid hormones that you have in the body. So just kind of So it helps to regulate the absorption of sodium ions and chloride ions in kidney tubules, and sort of by default in doing so, this is something that helps regulate water in your body. It's by regulating concentrations of ions, you're regulating by default water, because you've got things like diffusion and things of that nature that are related to concentrations of ions in your body. So as you increase aldosterone, it leads to an increase in absorption of sodium and chloride. Okay. And of course, as I mentioned, concentrations of ions like sodium in tissues influences retention of water, so of course this implies that aldosterone regulates or is involved with regulation Of course, there are conditions where your body is not able to get rid of the excess water. Certain kinds of issues with the kidneys can result in that kind of thing, and so your body no longer can regulate water balance, and so you get accumulation of water, swelling, things of that nature. Of course, there's the opposite of that, where your body flushes out too much water, which can lead to things like dehydration and complications from that. Okay. All right, so the next thing that I want to talk about are the sex hormones. And then finally, after that, I'll talk about prostaglandins, and that'll wrap up our discussion on lipids. Okay. So the sex hormones, most of us are familiar with things like testosterone, estrogen, and progesterone. Sex hormones are produced in tissues like the testes and ovaries. So we're talking, the male and female gonadic tissues. And so, of course, these lead to what they call secondary sex characteristics. So they will influence those secondary sex characteristics. And those are the things that appear at the onset of puberty and are obviously influenced by the sex hormones. So secondary sex characteristics could be things like development of breasts, development of hair on the body in various places, and of course things like in males where voice ends up lowering. And of course there are a host of other kinds of characteristics that are typically influenced by the presence of sex hormones. An example of those is, of course, muscle mass tends to increase in males as a result of the presence of testosterone. So male hormones, these are called androgens. So those are things like testosterone and testosterone derivatives. So testosterone looks like this. So this is testosterone. And then the female hormones, female sex hormones. So these are things like your estrogens and progesterone. So your estrogens are estradiol and estrone, and then of course progesterone, which looks a little bit more like testosterone in its structure. So if we look at your estrogens, This is so estradiol, so you see two alcohol groups, so the diol, and estrone, you see the ketone, so it's got that O-N-E ending. Very closely related hormones or compounds, right? So one is a ketone derivative of the other. And these are collectively what are termed your estrogens. Now there are other estrogen derivatives as well, but these are two of the most important ones that you'll see. And then of course we have progesterone, which I'll kind of show you. And so you notice here with progesterone, it's very similar in structure to testosterone. The only difference is that in testosterone you've got an alcohol group here on this 5-membered ring, whereas here you've got an acetyl group. So it looks like acetone in some way, so it's an acetyl group. Okay. So obviously, your sex hormones are important in the whole reproductive process. So not just with the development of your reproductive organs and your secondary sex characteristics, but the general reproductive process as well. Estrogens themselves are involved in development of the eggs and the ovaries, and of course regulation of the menstrual cycle and ovulation. And of course, progesterone is what causes changes in the uterine wall to accept fertilized egg and maintain a resulting pregnancy. So the interplay between your estrogens and progesterone is important in regulating that cycle.